Good day for everyone. Today we will discuss how to calibrate the power sector using a starter data kit, the OSeMOSYS model. The first step is to open our hands-on with the guidelines for doing the process step by step. In this practice, the idea is to learn the importance of collecting the input data of the power sector, essentially install capacities and historical generation, and secondly, the process of calibrating those parameters in the osmosis model. So the first step is essentially to do some research for getting the data. Two things are important, as we will see right now. The first step is regarding the start capacity, historical for 2015, because it's the starting year in the osmosis in the starter data kit, and secondly, the power generation, which will we see before later. So using information from national entities or other documentation that you can find in your country, it's important to consider that it's country specific, so it's going to depend on what is the data that you need to get. And as you can see in this example here, this is like how a table with information look like. This is just an example, so please keep in mind that it is not exactly the same for your country, and also depending on your data, your final year could be 2020 or 2022 or even 2023 if you have very outdated data. Okay, so for that purpose, it's very recommended that you try to create an additional Excel template, Excel document or Excel file where you can try to record what are the values for each technology in your country and the different years. This is a specific case of Uganda. So as you can see here, we have the different technologies, essentially hydro technologies, oil, biomass, and different off-grid technologies, and also some solar PV. In general, most of the times you will find technologies that are not exactly the same that you can find in the starter data kit. This is the template that we will use throughout our practice, and as you must know, they are like general technologies and codification that we use in our model, so this is not the same that you will find in your different countries. So please try to keep in mind that the idea is to try to match as much as possible the codification of the starter data kit with the different technologies that you have in your country. And also it's important to take into account that here we are represented aggregated technology. So if you have the data by individual plants or power plants, you will need to add the different technologies by group and then to report the values in aggregated way. This is the second part that is very important. So considering that is some work that you need before starting this practice, at the end you will have this kind of table with the different technologies and the different years with the install capacity. It's important to say that this is in gigawatts, and secondly that this is the generation, this will be in petajoules, and in the case of capacity, that is the second part, here we will work in gigawatts. Okay, so once you have that, and according to the first activity in our hands-on, the idea is to complete the first table of our hands-on here. Okay, so the idea essentially will be just to go to the different technologies. Like in this example, we have different hydros, so we just need to go here and try to copy and paste it according to your values. Also, let's remember always that the idea is to copy the values as values and the numbers as values and not with formulas, because it can cause errors in the processing of the data. Okay, so please try to keep in mind. The second, another thing that I need to mention here is that notice that this template is designed for values until 2022. However, in case that you don't have those values, the strategy here will be just to try to make this constant for the rest of the years. Okay, so in case that you have data until 2020 or 2021, in that case just make it equal to the other year that is missing, in this case 2022 it could be, just for instance, just to try to complete the template. Okay, that is another thing that I would like to mention. Now we have here oil. Here, for example, it is not defined if we are talking about the first kind of power plant, that is with light fuel oil, or maybe this is the type of gas turbine using also fuel oil. So in this case, just as an assumption, we will assume that we are talking about the first one. So it will be just to pay the values, and once again just make it constant. And once again we continue, we have biomass. In this case we have this, we can copy again, just extend the values. Here we have of hydro, so we can copy this. It will be just essentially, once you have the data, is more just like a process to copy and paste, so it's not a big deal. We have diesel standalone. Let's remember that this technology is essentially this one, light fuel oil standalone generator. Again we have this one, we have the values here, and then we have the other values here for solar. Just let me take a look, because I feel like the values were not processing in a good way. It was just like it looks like they were not copying essentially as I was expecting. So let's try to copy this and this directly, because yes, I'm not sure why it was not copying correctly. So let me try to do it just by hand. I don't know why the values were changing, so just take care that when you are dragging the values, they are effectively copying as constant values. Okay, here we have solar, and in case it would be just utility one. Here we have these values again. Now it's working properly. Here we have, oh sorry, this is the one for solar, my mistake. Here we need to copy these, copy values here. Now again, it's like, I don't know why, but the values that they are copied like in a strange way. Finally we have off-grid solar. We have solar here is this one, like this. Let's try it now. Yeah, it's working properly. Now regarding the historical install capacity, is working properly. Now for this case, as mentioned in the hands-on, we need to define what is the behavior of this install capacity. It means how is the process of decommissioning, so in which GR the different capacity or the different power plants are going to be uninstalled. Normally it's very difficult, especially for big power plant fleets, to really know how is the process of decommissioning. So for making this as simple as possible, we will take into account two different assumptions. One for hydro, just to keep constant, considering the high operational lifetime. In the second part is just for the rest of the power plants to perform a linear decrease in capacity from 2031 to 2050, just considering that we will keep as constant their current installed capacity until 2030. Once it is done, we just need to go again, just complete these values as historical ones, and secondly, automatically the installed capacity will be projected using the different formulas. So essentially you don't need to do anything else, just try to complete the blue part, and automatically you will find the different values for the rest of the years from 2023 to 2070 for the case of the starter data kits. Okay, now once it is done, we just need to go to our starter data kit and try to include these values using the parameter of residual capacity. Let's remember that residual capacity represents the installed capacity per year. So here we have our last file, that is the version 3. So we will do again, just copy and paste it to create a new copy. And then it will be our version number 4. We will complete this now for the new version. So the idea will be just to filter the parameter of residual capacity, and second to filter the different power technologies and complete the values one by one. Okay, it is going to take once again a little bit. In the meantime, just to mention that after completing this process, it's important to save the file and then run the model and checking that everything is working well, just for continuing with the next step. Because if we do all the steps, maybe at the end of finishing we can get an error or a failure on a feasible model, and then it will be more difficult to identify in which step is where we have the difficulty. Okay, so always try to, after any modification, just save and run the model. Okay, so here let's do the filter for power technologies. It will be PWR. Then we just need to filter our parameter for residual capacity, as I was mentioning before. So here we just need to look for residual capacity, and after doing that we will get the different values. Okay, here we have some values. It will be essentially the same for your case. We will try to do it now for our case here. So notice that here we have more or less good values. Sorry, this is not the file, it's this one. Here we have the values, so we just need to go to our timeline, just copy the values, go to our starter data kit, paste the value, and then go again. You just need to put 0. So life fuel in this case would be the next one. Go copy, it would be this. Notice that here we have like a hint, because the values are reported for the second technology. So maybe it was a wrong assumption from my side to say that it was the first technology, but here with starter data kit it is saying that it's the second one. So let's go with the second one. So now we have it, and then let's do so on and so on. So it would be like, for example, here notice that hydro number 3 is not reported, but in our case we have data, so we need to include it here. But essentially what is going to happen is just try to complete technology by technology using the data that we have here. So I'm just going to do one final example just for solar. Just like take it, copy, go to your parameter, look for your technology, that is this one, solar 001. Then copy this as values, and that would be everything. Like, just again, step by step, do it for all the technologies, and after that don't forget to save it, and that would be all. I'm not going to do everything because it would mean to spend too much time just doing something that you can do on your side very easily. So it's just for showing you how the process would be, but let's remember that it's essentially to do it. And once again, please, once you are done with this part, save the file, then generate the input data file and run the model locally or using the OSeMOSYS cloud, just for checking that after these changes your model is still running. Okay, that is very important. Good. So being said that, as you can see here, it's essentially the same steps. The second part is about the plan install capacities. It means it would be what are the future projects that are like very sure that is going to be online in the next years. So for example, here we have 4 different projects. This is just like an example. It's not the case for Uganda, it's not the case for any country, it's just for showing you how it would look like. So in our case, for example, for Uganda, we have like there is a plan for install a new medium hydro power plant in 2026 with a capacity of 80 megawatts. So the first step would be like in the starter data keys, we are always working with gigawatts, so it's important to convert from megawatts to gigawatts. So the idea would be just to divide 80 by 1000. In that way we can find the gigawatts. It would be 0.08, right? So let's assume that it is going to be the unique plant install capacity that we will consider in the model, okay? So obviously that for your country cases, they could be 2, 3, 4, any number of new projects that you know that they are like very secure and they will be online in the next years. So you can include as many projects as you need. Just take into account that you will need to do it one by one again. Okay. So for this example, I will do just this example, but you can do it on your own with any number of projects that you consider for your modeling. Okay. So what is the parameter that we need to use here? The name of the parameter is the total annual mean capacity investment. So I'm going to remove the filter for residual capacity and I'm going to select this one, total annual mean capacity investment. It represents a forced investment in a determined capacity because you are saying that to the model. So in this case, we're going to go with 0.08 gigawatts for the case of medium hydro. Let's remember that medium hydro is hydro 002. So in this case, we just need to go to the GR. This is different from the previous exercises where we use the same number for all the GRs, as this is a very specific GR where the investment is made. It's important to put the number just in that specific GR. So in this case, we go to the technology 2026 and we put 0.08 gigawatts, and that would be all for establishing this value as a planned install capacity in the future. Okay, so that would be the second step. Once again, you can save it and we can continue with the next step in this calibration. The third step in this calibration is pretty similar to the one of install capacity, but this time is regarding to the power generation. It means the historical power generation. Once again, we need to complete a similar table to the table 1, but with the data of electricity production in petajoules in this time. So here we have again an example with the different values in petajoules from 2015 to 2021. It's important to take into account that if you are calibrating from 2015 to 2020, for example, for the case of Uganda, in terms of install capacity, the idea is that you use the same time frame for the electricity production, so it would be 2015 to 2020 once again. Okay, so if we go to the template, we just need to, okay, I forgot to say something. Here you have an additional tab. Is this one just like an example, like if we try to replicate what we were doing before, is just like, for example, here we just need to use power hydro 002. That is essentially a hydro power plant. Here it's important to say this one. Here I'm missing a D. Then it's 2000. 262008. Okay, so you can complete this kind of table and then just to migrate all the values to the structure data kit. The third tab that we have here is generation existing, that is the historical electricity production. So once again, the idea is that you do some research. So here we have the exercise after that. These values are already in petajoules, take into account to perform any conversions if needed, because normally electricity production is reported in gigawatt hours, so take into account to do the conversion. Here we have in petajoules, so once again we just need to complete the table in our template. We just need to complete these values and we will assume the same process that we did before. It's just like as we have values until 2020, we will assume that they are constant for 2021 to 2022 in this case. But obviously that if you have outdated data, you can do it until that year. Okay, so here just for showing you how the process is, so we just need to copy large hydro, then we go to large hydro. Here you can copy the values, just make this constant, and notice that automatically once again the historical production is populated. You can read the guidelines and you will see what are the assumptions that are essentially the same, constant until 2030, and then constant for the case of hydro technologies, but with a linear decrease until 2050 for the rest of technologies. Okay, so here again, if we want to populate the other ones, it will be essentially the same. Just copy these values, then you can extrapolate it. Okay, I know what is happening. We need to do this like this one just to keep it constant. Then again, we need to do the same for the other ones. We discover that this value was for the second one, so it would be something like this. We put the values here. Okay, it's the same, and we need to repeat the process for biomass, for solar, for the other off-grid technologies, and then that would be all. Okay, now once this is performed, is conducted, we can go to the file and then to complete this and then to include these values as parameters. So what is the parameter that we need to use is the total technology annual activity lower limit. So we will look for that parameter. Is here, is total technology annual activity lower limit, is this one. So we select it, and now the idea is essentially just to copy and paste the values that we have in the template essentially here. So you can take it, remember that you need to take the whole time series, so it would be just like this one. Then you can go here and you can paste it. Please take into account something that is very important, is that although it looks like it's quite easy just to copy and paste the whole series, yes, because maybe you are thinking about that maybe you can take all the values like this one, then copy and then go here, yes, something like this, and then paste it. Notice that it is not correct, because between the different technologies, for example here, between this row and this other row, we have some intermediate rows. So if you go and copy this, what is going to happen is that you are going to copy the values in the wrong cells, because you have some hidden cells between the ones that you already have here. So please avoid to take as a whole set of values, but instead of that, just do it one by one in order to guarantee that all the values are copied correctly. Okay, so just one final example. Let's go with hydro. So you have large hydro here. Just copy the whole series, go to the data. Here we have 001. We just need to copy and paste that, and then repeat the process for the rest of technologies accordingly. Okay, that would be the third step in terms of calibration. Now the fourth step is regarding the fourth step would be regarding imports and exports. For that, in our calibration template, we have a fourth tab here that where you can have you can report or complete those values. In the case of Uganda, that was our original example, notice that here we have a special cell for imports. In the case of this country, there are no exports, so they will be 0 by default. But here we need to consider exports here, so sorry. So in this case, we just need to copy these values, and then we can complete this part, right? Notice that here imports became 0, so it would be essentially 0 here. So after that it would be 0. However, maybe you have different imports. These cells are already formulated to provide some kind of estimation or projection, and you can read how the assumptions are proposed in the calibration PDF file, okay, the hands-on. After doing that, we need to do something that for the case of imports and exports is like kind of special. So let's try just to select power imports in this case, that is this one. And here you will need to put the time series in two parameters at the same time. It would be for the lower limit, as we did before for the electricity production, but also we'll use the annual activity upper limit. This is because in terms of imports as exports, they could be a behavior where we don't have enough availability for doing imports and exports in a huge way. So it's better to guarantee that we're going to use just like add a specific value for each year. So that's why we need to input the value the same for both parameters, both the lower one and the upper one. So here we just need to take it, so just copy, go to the template and paste it for both, just like this one. Again, let's remember to do it one by one. Then we just need to save it. That would be all. In case that you have exports, it would be essentially the same. You just need to complete the values in your template, and automatically you will get the time series, and after that just copy and paste it into the starter data kit. Okay, now the fifth step here is regarding the electricity demands. So let's remember that for the case of the starter data kit, we work with 3 different electricity demands: residential, industrial, and commercial. Okay, so in that case, we need a source where we can find the different demands. Essentially, my recommendation would be to work with the net energy balance, because we are talking about electricity consumption in the end use. So for that reason, it's better to use that instead of the, for example, power utility in your country. Okay, so in the case of Africa, one good source of information is the energy balance provided by the African Union. So in this case here, you can see the web page with the link in case that you need it. The idea will be to populate the values for each year. So just let's use one example with 2015. It is loading, and after that we will select Uganda as country. Sorry, it was not working. Just let me select first Uganda, and after doing that we can go with the country. So in this case we start with 2015. Now it's working good, and here you can see that if I scroll down, you have the final consumption for the different sectors, right? And we can see that for electricity, that is over here, notice that we have here is this one, we can get the values in terms of kilotons of equivalent oil. So this is another thing that we need to consider. It's like we need to do the conversion between kilotons against petajoules for our case. Okay, so notice that for transport we don't have any electricity consumption, so it would be just 17, 18, 45. So in this case, let's go to a calibration template. Now we will use the demands tab for doing this. Yeah, essentially we'll need to complete this part, like electricity demand for residential, industrial, and commercial, plus others, because sometimes you have other sectors, like for example mining, agriculture, etc. So you can add those values to the commercial sector just for considering all the electricity demands. And so here we need to do like this extra calculation. So let's consider that it would be for residential, the value is 45, so it would be 45. Then we have industry 17, and finally we have 7 commercial. We don't have other sectors in the energy balance, so that would be all. This is in kilotons of equivalent oil, and we need to find what is the value for the conversion factor. So let's check it, kilotons to petajoules, and it will give you a value. So here is saying that is around 0.04. Just let's try to check it. Unit converter, let's check this source just for checking, because I think I know how to do it, but I just want to guarantee that it's working properly. So okay, we have tons. It says 1 ton of oil equivalent is equal to 41.97 gigajoules. So it means, okay, let's do the conversion here just to be completely sure about this. So we are saying here that one is 41.87. We are taking here ton, so, and here gigajoules. So in this case, for example, it would mean that in terms of petajoules, it would be this value divided by 1 million, right? Yeah, 1 million in this case. So it would be like this one. But if we want to do it in terms of kilotons, yeah, if we go with kilotons, it means that it will be divided by 1000. In fact, if we want to do the value for kilotons to petajoules, right? Kilotons to petajoules. Okay, so this would be this value. So we just need to, in this case, multiply this times this value. Need to lock it, and that would be the value in terms of petajoules. So we just need to copy this, paste it here, and that would be our value. And we need to repeat the process for 2016 on all the years. And again, as you don't have these values here, you just need to make it this constant if necessary, or just wait until here, because essentially you can try to extrapolate the values after that, so it doesn't make any difference at the end of the day. So here, the second part of this is like, after completing that, you need to guarantee that the error percentage is essentially less or between -5% and +5%, right? Notice that here right now is like you have a very big difference. I have to say that probably the values are not the more accurate ones, so that's why the difference is quite a lot. But maybe if you are using a good resources, probably the difference will not be so high. Okay, so now the idea is how we can correct this, because the behavior that needs to be good. So here we are going to play with the transmission and distribution losses. So if we manipulate these values doing some kind of trial and error, we can try to to fix this. So for example, let's assume the transmission is incorrect, and then it could be 85%, and then let's say the distribution are also wrong, so let's say that is like 70%. So notice that here the value is changing, is less. Once again, it is going to be, it's just an exercise, like an example, so this is why probably the values are not the best one, and probably the transmission and distribution losses are not going to be so small, but it's just for this case, just as an example, okay? So let's play once again. Let's say that here is 0.5, sorry, 0.5, and now let's say here is 0.4, right? Notice that here we are always there. 0.45, we are almost there. Here let's say 0.55, and right now we have an acceptable value, okay? So here this would be our new transmission and distribution losses, and automatically it means that we need to update the input activity ratios for both transmission and distribution. Notice that here we have that calculation. As we don't have more data here, I'm not going to do the same example, but just let's assume that the value is going to be essentially the same for the rest of the GRs, just for showing you how is the process. But obviously that in case that your values here for the different percentages are outside the tolerance range, it will be important just to continue playing with the losses of transmission and distribution in the different GRs. So please keep in mind that part, okay? So just to recap, try to complete the energy balance for the other GRs, try to play with the transmission and distribution and complete this, okay? Also, I'm going to do this with constant values because I want to show you that automatically we can generate the projected demand. How we are going to do that? With a growth factor that it could be, for example, the average GDP growth expected by your country. So let's assume, for example, that the expected GDP growth in Uganda is 3.5. So the growth factor would be 0.035, and automatically you will get the values for the different demands, okay? This will be automatically, so you don't need to be worried about this. It's just going to be like that, and that would be all for the different transmission and distribution part. Notice that here we have from 2070 we have errors, higher errors. So for example, let's go to 2017. We can just try to modify this. Let's say that it increased a little bit. Okay, it's not working. So now here we have, let's say 46. Now it has to be less apparently. Yeah, let's say that it decreased. It should not be like a decrease as such, because essentially it should be more like that, more than that, but let's consider that is like that. Then we will repeat the process. So let's say that is, for example, 51, and then you know that automatically the values are changed. This is basically the same. Here is not changing enough, so 0.4, and here we go from 16 to 3.4, so it's going good. And again, we can repeat the process with the rest of the values, and automatically we will have these new input activity ratios, and we need to update that, okay? So now the question is, where should I update the starter data kit with these new values? So essentially we can go here to the parameter. What is the parameter for demand? So let's remove the filter for technology. Now we will use the parameter of specify annual demand. So we can find in here is this one, specify annual demand. and we will update the values for the three electricity demands: residential, industry, and commercial. So for example, here we can see that these are new values for residential. So we just need to go here, we look for the value that is this one, residential is this one, we can copy, then we come back, let's check industry, select industry, go again, industry is here, copy and paste it, and then we go again, we have commercial, select it, go to starter data kit, and paste it as well. Don't forget to save it, and that would be for the demands. The second part of this step is to update the input activity ratios for transmission and distribution. So we need to look for that parameter, that input activity ratio right here. We select it. Now let's remember that the codes for transmission are essentially, let's look for PWR first, then and select this, and let's remember that we have first for distribution is this one, but PWR dist, this is the first one, and for transmission we have PWR TRN for transmission. So we can select those technologies. And then let's remember that the input field for transmission is electricity 001. So in that case, we just need to update it. So we can go here. I think we have a different value here, but we will check this later. We need to copy this, go to this value, we can copy and paste it. Then for the case of distribution, the input field is electricity 002. So once again, go, take it, go and paste it. And I think we need to review the output because it is kind of strange to have 1 as input activity ratio. So just check the output because probably it is different from 0, different from 1. Yeah, so here they are working inversely. So we just change this by 1 as is the common way to do it. So let's change this by 1. And again for this, let's change this by 1. Good, and that would be essentially all. We can save it. This was like an extra step because I was not considering that in the starter data kit these parameters were calculated differently, but essentially it's just a little extra thing that we need to do, but it doesn't match too much difference. Okay, so that would be all for the part 5. And then we need to do part 6, that is transmission and distribution. I'm not going to do it for this video because it means to save it, create the input, run the model, but I hope that following the different instructions you can do it quite easily. So just continue and do it. And finally, just to mention that to deactivate technologies like, for example, countries with no possibilities of nuclear power plants, or if your country doesn't have a coastline, you can deactivate technologies just setting the total technology annual activity upper limit equal to 0 for all the GRs. So it's just something like this in this example. And that would be essentially all for this video. And thank you so much.